All right, folks, welcome back. Hope everybody had a restful Christmas break. We are resuming chapter 3, discussing logarithms and properties of logarithms, which we should have gotten some of that in Algebra 2. And we discussed some things before break, so just real quickly, we're going to go back over those things and review them to make sure we remember what we're doing. The first of those things is how to convert between logarithmic and exponential form. Again, up on the screen, you'll see the equation for that. On the left is logarithmic form, and on the right is exponential form. These are the same expression written out in our two different forms. Okay, so log base b of n equals x is exactly the same thing as n equals b to the x. So the first thing we talked about right before we went on break is how to convert between these two forms. Number one is in logarithmic form, where our b value is 3, our n value is 9, and our x value is 2. So we would convert this and we would have 9 equals 3 squared would be the exponential form of that logarithm. Again, those two expressions are identical. They say exactly the same thing. Number two is already in exponential form. Again, we've got n, b is 4, and x is 2. So when we convert that into the other form, it would be log base b, which is 4, of n, which is 16, equals x. So log base 4 of 16 is equal to 2. So take about, I don't know, 30 seconds and convert number 3 and number 4, please. Number 3 is in logarithmic form. Please convert it to exponential. Number 4 is in exponential form. Please convert it to log form. Make sure you remember what you're doing here, because this is going to be important going forward. When we get to Friday and we're solving equations, we are occasionally going to have to convert back and forth. So take a second, try those two, get out ahead of me here. Again, there's not a whole lot of work to show. Pretty much you're just going to convert it. So there's not really a whole lot to show work-wise. You just got to write it out. So what are those in their opposite forms? Maybe 15 more seconds. It should be quick. I believe that the quiz is covered this. No, actually, it might have been the Delta Math. One or the other. One of those two assignments, the quiz is and a Delta Math, covered this skill. Those of you that still owe me the quiz is, I did start a new game. I updated the game code. It's on the comment of the assignment itself. I emailed it to those of you that still have to do that assignment, but if you wanted to improve your score, the game code is in PowerSchool as a comment on your grade, and you're welcome to do that quiz is again for a better grade as many times as you want to. Okay. All right. So number 3 is in logarithmic form. Log base 4 of 8 equals 3 halves. When we convert that into exponential form, that would be 8 equals 4 to the 3 halves power. That would be the exponential form of that logarithm. Number 4, it's already in exponential form. When we convert that into a logarithm, it would be log base 144 of 12 equals 1/2 would be the correct logarithmic form. Okay. Any questions on that piece of the review before we advance? And all I'm doing here is grabbing a quick snippet of that for our completed notes. I'm going to drop that in here real quick. Any questions on that skill before we move on? You can unmute and ask. You can type your question in the chat. Either or is fine. So this is our first skill we did before break. We're okay? Hey, hi Colton. Welcome. Updating my tenants. Okay. So on to the next skill then. The other skill was using the calculator to evaluate logarithms. Keep in mind that your calculator is only capable of evaluating logarithms in two bases. Base 10, which are called common logarithms. That's where we have log with no number, okay? That is a common logarithm. It's the log button, which is on the left side of your calculator, right next to 7. And logarithms with a base of e, which are known as your natural logarithms. And the notation and the button is ln, which is also on the left side directly underneath the log button, right next to 4. Okay? So again, just as a reminder of how we evaluate those, when we type those in the calculator, we're going to hit the appropriate button, either log or ln, depending on whether it's a natural log or a common log. Okay, so I'm writing out the keystrokes here. Simply put, you're going to type that in. That's all you really got to do. Log 38, enter. And that is 1.5797. And then that fifth digit that we used to round is an 8. So we should have 1.5798 for our answer on number 5. The nearest 10,000th is 4 decimal places, so we look at the fifth digit to tell us how to round. I hope I don't need to do a lot of reminding on how to do that. So on the second one, natural log of 24. Again, we hit the LN button, 24, and then enter. That is 3.1780, and the fifth digit that we're using to round is a 5. So we should be rounding the 0 up to a 1, 3.1781. Try the other two real quickly. It shouldn't take very long at all because all you're doing is typing in the calculator. Get answers there so you can compare them to mine in about 15 seconds. Again, it's just all about hitting the correct button on the calculator. And then rounding correctly. So log of 122 is 2.0863. Next digit is a 5, so we should be rounding that to 2.0864. Natural log of 3 is 1.0986. Next digit is a 1, which means we're going to round that down and just keep it as a 6, 1.0986. We will review the other skill from right before break at some point, but that's not going to be today because we don't need it today, that being the change of base formula. But when we need that, we will talk about it, okay? So let me stick that in my completed notes here. All right. Any questions on using our calculator to evaluate logarithms before we advance to the new stuff, newish stuff? Everybody okay? Any questions? Now is your moment. All right. So moving on. The next thing here, exponent rules. And this is just, we're going to briefly talk about this here, show an example of each. These three rules are things that we learned in Algebra 1. We use them again in Algebra 2 in a harder detail, okay? But these three rules we should know, starting with the product rule. When we multiply two exponentials that have the same base, so say we did, I don't know, a to the third times a to the fourth, we are supposed to add those exponents. So 3 plus 4 is 7. When you multiply the bases, you add the exponents. It wouldn't matter if those were numbers being multiplied. Okay, either way, we add the exponents. If the bases are the same, we add the exponents. If the bases are the same and we're multiplying, then we add the exponents. The power rule says that if we take an expression and we raise it to another power, so 3x, a to the third to the fourth, we multiply those together to get a to the 12th. Same would be true for numbers. It wouldn't matter what those numbers are. We would simply multiply the exponents. 3 times 6 is 18. And finally, the quotient rule says that if we have two expressions in a fraction that have the same base, we subtract the exponents. So 5 minus 3, which is a squared. Same thing would be true for numbers. Okay, 12 minus 4 would give us 3 to the 8th. Okay, so this is basic algebra stuff. I would assume we're probably okay with it and don't really need to spend much time discussing it. Okay, because again, these are Algebra 1 rules that we've used in Algebra 1 and Algebra 2, even a little bit in geometry, but not till the very end, so not really. Okay, but we've used those throughout algebra. Those three rules should not be new stuff for us. It should be relatively simple stuff we already know. So again, any questions before we advance into these exact same rules written in logarithmic form or logarithm rules? Okay. Well, in that case, let's get into what is now considered to be newish, and it's not really super new because you should have learned it in Algebra 2 right at the very end of the year. My class did, although we did it during virtual learning, so who knows how much of that actually stuck. But if you had me for Algebra 2, we did learn this last year right at the end of the year. So we're talking logarithmic. It's great that that's on recording. Let's try that again. Okay, now we're into logarithm properties. Okay, and the wording is a little bit confusing, but I'm going to read it anyway. Okay, if b, x, and y are positive real numbers, which means they're not 0, they're not negative, and b is not equal to 1, and p is a real number, any real number, then the following rules are true. The product rule. Now remember what we said before, right? These are the same rules as the exponent rules. They're just written in logarithmic form. So if we have a logarithm that contains a product, log base b of x times y, that can be broken up into two separate logarithms, log base b of x and log base b of y, being added together. Quotient rule for logarithms. If we have a logarithm that contains a quotient, log base b of x over y, that also can be split up into two separate logarithms, log base b of x minus log base b of y. Your numerator is your first logarithm minus your denominator, which is your second logarithm. And then finally, the power rule for logarithms. If you have a logarithm that contains an exponential expression, log base b of x to the p power, you can grab the exponent p and move it out in front of the logarithm as multiplication. So log base b of x to the p power is p times the log base b of x. So we're going to use this in two different ways. We're going to use it to expand logarithms and combine logarithms. Okay? So we'll start off with combining logarithmic expressions. Okay? We got the directions here. Write the expression below as a single logarithm in simplest form. So on number one, we are going to take that expression and we are going to use the logarithm rules to combine it down into a single logarithmic expression. So the first thing we do is we have this 2 in front of the first logarithm. We are going to use the power rule to move that 2 up and make it an exponent on the 4. So that would give us the expression log base b of 4 to the second power minus log base b of 4. Now, once we've done that, we look to see what sign is between those two logarithms. The sign between those two logarithms is a subtraction sign. So because of the subtraction sign here, we are going to use the quotient rule to combine these two expressions into the log base b of 4 squared over 4. We're going to combine it using the quotient rule. And then the last thing we have to do is simplify. Okay, that expression is not in simplest form because 4 squared over 4 is a number that we can find. So 4 times 4, 4 squared, is 16 divided by 4 would be 4. So we just keep working our way through until we have the simplest expression that we can, which would be log base b, it should be a b, of 4. And that is a single logarithm that has exactly the same, it's exactly the same as the initial statement, but it's in simplest form. We've combined those logarithms until we only have one, and we've put it in simplest form. Okay? All right. Letter B is a much simpler example. There are no numbers in front, so we don't have to deal with the exponent rule. But we do have a plus sign between our two logarithms, so we apply the product rule. And we rewrite this as log, keep the base of b, of 8 times 2. Now we've condensed it down to a single logarithm. We just need to simplify. 8 times 2 is 16. So our final answer would be log base b of 16. Try letters C and D, please, on your own. I'm going to give you about a minute to do so. Okay, letter C should be very simple. Letter D is a little bit harder. Please combine those logarithms down to a single logarithmic expression in simplest form. This is what you're going to be asked to do on your homework tonight, so please make sure you get the idea here by trying on your own. Don't just wait for me to do it, or else you may have trouble on your homework. Give those two a shot, letter C and letter D. Combine those down into a single logarithm and write it in simplest form. Letter C should be extremely quick. Letter D might take a little bit longer because it has some letters in there. So you won't be able to do a whole lot other than put it together. Okay. So again, we need to follow sort of an order of operations thing here. We have to get rid of this 2 first. It's in front of this logarithm, so I can use the product or the power rule to make it an exponent on the 3, which would give me log base b of 4 plus log base b of 3 squared. You can write 9 there as well. That would be fine. You're going to have to at some point anyway. Then, now that we're down to just 2 logarithms being added together, we are then going to apply the product rule, because there's a plus in between those logarithms, to rewrite this as log base b of 4 times 3 squared. And then from there, all we need to do is simplify 4 times 3 squared. Well, 3 squared is 9. 4 times 9 would be 36. Log base b of 36. That's it for letter C. On letter D, both of our logarithms have something in front. So we're going to use our power rule to make those exponents. So our first step should be log, which again is a common logarithm, so that's a base 10, log base 10, of b to the q power plus log, again that's base 10, there's no log written, so that's common, of k to the third power. So our first step is to move those things from in front of the logarithms up to be exponents. And then we have a plus in between. So we are then going to apply the product rule because of the plus. And we're going to combine those by multiplying, which would give me log of b to the q power, k to the third power. We cannot simplify that any further. That is in simplest form. So we're done. That is how we combine. I'm going to grab a quick screenshot, and then I'll put it back up there and take questions. If you've got any questions, prepare them while I get this transferred over to our completed notes. Oops, that's not what I wanted to do. There we go. Edit, paste. Okay, so that's combining. Any questions on combining? Using our logarithm rules to combine. Any questions on how to do that? Because that's 15 out of your 25 questions on your homework. Any questions before we advance to the next step, which I believe is the last step of the notes for the day? Alrighty, so we're going to move down the page then, and we are going to expand using those rules. Okay. Okay, so just for reference sake, again, we've got our 3 logarithm rules. We've got our product rule, which says that we can combine them using multiplication. We have our quotient rule. And I may actually be writing these in the reverse order that I listed them a minute ago, as in left and right side switched, but that's fine. Okay, and we've got our power rule. Okay, so those rules are actually on the notes further up the page, so in theory you shouldn't need to rewrite them, but I need to for reference. When we look at this first logarithm and we're supposed to be expanding it, the idea is to break that expression up and write it in terms of log of x and log of y. So what we do, what we have to recognize is we have to see the division. Okay, and the first thing we see with the division, we should then go, oh, well, that's quotient rule, and rewrite this as log of x to the fourth minus log of y to the fifth. So we break it up into two separate logarithms, and since it was division in the original problem, we use the quotient rule, which means there should be subtraction between those two logarithms. Then the only other thing we can do is both of these expressions contain an exponent. So we're then going to grab those exponents and move them out in front of the logarithms. So our final step here would be 4 times the log of x minus 5 times the log of y. And that is written in terms of log of x and log of y. It is expanded. So that is how we expand. So that's the first example. Let's go on to the next example there. Log of x to the fourth, y to the third. Again, we need to recognize that x to the fourth, y to the third is a product. It is being multiplied, which means I can split it into two separate logarithms. Log of x to the fourth plus is the key. These two logarithms would be added together because we're using the product rule, which is purple, plus the log of y to the third. So we take the multiplication expression, we break it into two separate logarithms with a plus sign in between, because the product rule says if a logarithm contains a product, it can be split into two separate logarithms being added together. And then just like we did on the previous example, once we get that expression broken up, we grab the exponents and we move them out in front using the power rule, which gives us a final answer of 2 times the log of x plus 3 times the log of y. So same deal. I'm going to give you a couple minutes, probably 2, to try examples G and H. So please expand G and H out until they are written in terms of log x and log y. On G, that one should be relatively simple. On H, remember that roots and exponents are really the same thing. So that cube root of y to the fifth can be written with a fractional exponent. So keep that in mind. Okay? Keep that in mind. Try those two examples. We'll go over them in about 90 seconds or so. About a minute and a half to try those. See if you can either get them or get stuck. And then we'll go through them together. See how we did. Again, just as a reminder, you did have a quizzes assignment and a Delta Math assignment the week before break. And there are still some folks that have not done those. I again restarted the quizzes. There's a new code. That code is in PowerSchool as a comment on your grade. Okay, so in theory, if you went into your PowerSchool app and clicked on the grade that you have, it'll give you the code for you to try again or try for the first time, depending on your situation. And then the Delta Math, perhaps the reason why some of you haven't done that is you're having login issues. If that's the case, you need to contact me so we can get those login issues fixed. Semester ends Friday, folks. We need to have this stuff done sooner rather than later. As you do those things and you finish them up, please email me so that I know to update your grade. About another minute on this problem. I know I'm talking incessantly, which is probably hurting some of your focus, but give it a shot. Try that next one. C, G, and H. Try G and H. G should be relatively easy. H, not so much. H is harder. G should be relatively easy. H should be relatively not easy. Okay, on letter G, again, we should recognize that 5x squared is a product and apply the product rule to break it into two separate logarithms. Log of 5 plus the log of x squared. Once we've done that, the only other thing we can do is grab that exponent of squared and move it in front, which would give us log of 5 plus 2 times the log of x, which is expanded. That's done. On H, the first thing I would do is I would rewrite this as y to the 5/3 power, because remember that this root is a fractional exponent. The 5 is the numerator, the 3 is the denominator. And then I'd leave the bottom alone, x cubed z to the 4th. All right, so then we have to see the division symbol and recognize quotient rule. So we see this, and we break that up into two logarithms. Log of y to the 5/3 power minus the log of x to the 3rd z to the 4th. Then we should recognize x to the 3rd z to the 4th is a product, which means that this is log of y to the 5/3 power minus log of x to the 3rd plus the log of z to the 4th. And I'm putting that in parentheses because those two would have to be recombined before the subtraction is addressed so that they both end up on the bottom of the fraction. See what I'm saying? So those need to be in parentheses. Last step, the last thing that we can do is each one of those has an exponent. So we would grab the exponent and write it out in front of each logarithm. Okay? So our final answer would be 5/3 times the log of y minus 3 times the log of x plus 4 times the log of z. And that would be our expanded form. Fully expanded. Now, none of the ones on your homework are going to be that hard. Okay? I just wanted you to see a super advanced one. And we will probably spend more time on the harder ones when we're back in person. I feel like the harder ones, we probably all need to be in the same room so the questions can get answered along the way. Okay? So E, F, and G are the ones that are going to apply to today's homework assignment. Any questions on E, F, or G? Okay. Folks, your assignment is